to start the next one.
No worries whatsoever. So, all right, well, thank you, everybody. My name is Kevin A. McGrail. Most people on the internet know me as Cam. I work at a company called InfoShield, where I'm the Director of Business Growth, and we do cyber physical security for critical infrastructure. And so what my talk today about is, as it says, a cybersecurity expert's guide to secure programming. The reason for this is basically I want to stop programmers from being the next cause of a cybersecurity incident. So if you follow these rules and you kind of do it, you can, avoid being part of an incident response when there's an issue. So a little bit about me. Let me see if I can get the slide thing to work. Yes, there we go. So an introduction to me, is not too important, but what is important is my security expertise. So some of the things I've done over the years, I work very heavily on the Apache Spam Assassin project. I'm the key author of the cam.cf a rule set for Spam Assassin. I helped with the hardware for the first intrusion detection system, later bought by Cisco. I also help a lot with Mime Defang, which I'm happy to now announce AppRiver and Zix has donated that to the McGrail Foundation. So we'll be continuing running that. That is a Perl framework. I spoke about that last year. And with Perl, Spam Assassin, and Mime Defang, you could do some really, really cool things with email security. Also, I've had an FBI raid. So, I've also had my office filled with penguins, and I've got an apology letter from the FBI. And I had my phone lines cut before I was 10 years old. So don't do the things I did. Most of this is to learn from other people who've been through these problems. I also have an exploding race car. It's one of the few stories I'll tell today. When my driver had blown his engine, dumped oil all over the manifold, it exploded in flame. And this fire was so hot that this picture was actually taken in the afternoon, about 3 o'clock, bright sunny day. But that's how much we had to overexpose the picture and how bright it was that you could barely see it. And when he did it, my company's logo was on the hood, and I told him it wasn't straight enough. He had to go do it again. So in any case, just wanted to add a little story to start. But that does lead into what I call tone setters. So with the tone setters, one of the things I like to point out is I will use humor. I do talk about these things with a little bit of tongue in cheek. I love referencing company or organizations like XKCD, wonderful comic for comic and administrative information for geeks. But that does not, really, I don't want you to discount that I'm serious about this. I do have people that I help, people that call me crying, people that send me, missives where they need major, major help. So the main thing here is, humor is, I think, how I kind of survive dealing with this serious stuff. Please don't take it as an insult to the seriousness of the situation. The next thing I want to go over is anybody who's working in cyber, anytime you're doing anything that comes into cyber, make sure you have a rules of engagement, or what's known as an ROE. What the rules of engagement do is very simply set the boundaries of what you're allowed to do. So for example, if we're hired to penetration test a device, the rules of engagement will say what times and what days we can do the work on. It might say we're not allowed to touch the equipment or allowed to dismantle the equipment, things like that. But the key thing is when you're doing secure programming or security assessments, you need to make sure you don't break the rules of engagement, and actually can be a crime just to do that. So you want to think about what you're doing. Don't just start doing this stuff. Don't be the next example that has to call me for help because you cut and pasted something off a website that you had no idea what it was doing. And now you have the law enforcement people contacting you to ask you why you were attacking a server that you weren't allowed to. So the next thing is kind of the question before we get into what I call my dirty dozen, but what makes a high-end security programmer? So this is kind of the thing that people ask me. And so the first thing I talk about is that you document your concerns. If you think there's a security issue, write it down. Disclosure is huge, and getting an ethos of transparency is very, very important. Additionally, what I like to see is I like to see companies that set up a community where transparency is prided. That doesn't mean you can't give somebody grief if they cause a big security bug, but beyond giving them grief, nothing else. They shouldn't be fired for it, etc. Code has bugs, programs have bugs, they're going to have security issues. It's how you deal with them and how you fix them that separates you from other programmers. The next thing I talk about, and I'll talk about this a little more, is you got to think evil. try and think how the bad guys are going to think. Think about how people are going to use what you've designed, and they're going to get into the system. The next thing you do is what I call prove if you're right or wrong. What this means is follow your rules of engagement, don't exceed them. But if you think there's a security bug in the code that you're designing, go ahead and try and make an exploit for it. Try and prove whether or not you can do something with the code that it wasn't intended to do, especially something with elevated privileges. And then when you do that, ethically disclose the issue. The ethically disclosing the issue is probably the most important part there. We'll talk about that a little bit more in my Dirty Dozen. But I want to hammer a little bit about the Think Evil, because there's a pretty famous book in the marketing world called Start With Why, Simon Sinek, I think is his name. And so for us, I want to kind of get you with starting for why you need to do this. As I talked about, I don't want you to be the next programmer that I have to grill to say, okay, what did you do? How did they get in? What did the hackers do? What's the possibility? Let's go through the code, find out what actually caused the issue and how to fix it. And so we do a lot of threat modeling. What that involves is we think about it from the bad guy standpoint. How are they going to get in? How could they get into the servers? If they get into the servers, what can they do with it? What can I as a bad guy do with this data? And a lot of that is very important. You have to think outside the box with this. One of the ways that you can get some experience doing this, MITRE has what they call the attack framework. The attack framework goes over what is called the tactics, techniques, and procedures, or TTPs, for bad guys. And if you go through it, it's basically more about reverse engineering a hack, but you can look how they have documented all the various ways of getting into systems and think about it from that standpoint. On the same manner, Unit 42 at Palo Alto Networks also makes what's called adversarial playbooks. So these are reverse engineering what bad actors did, how they played their game, their playbooks. And so it's kind of like getting the playbook for the adversary, the opposite football team, so you can find out what they're going to do during the game. Same type of thing. Study their playbook, and you might refine your tactics to defend against it. Additionally, OWASP has a great security coding checklist. It's about 10 pages long, very simple checkboxes. It doesn't go into a whole lot of why, and that is one of the problems with it. But other than that, if you can check all those boxes, you're doing really, really well on a program. And you'll see that the thought process around this is to get people to pass things like an OWASP security coding checklist. Additionally, I want to mention people who aren't familiar with various security frameworks. A wonderful one to start with is called PCI DSS. That's the Payment Card Industry Data Security Specifications. What that is that's a security specification needed so that you can hold credit card data or accept credit cards. And a lot of companies in the United States and around the world are required to follow PCI DSS. It's a self-assessment questionnaire, or an SAQ, so you can find it online very easily. And if you can go through that, and your network and your systems and the design you put in place with your entire ecosystem can pass a PCI DSS scan, you can rest pretty well that you've done a good job of designing the system to avoid being hacked. All right, next thing, the CIA triad. So this has nothing to do with the CIA agency in the United States. This just stands for confidentiality, integrity, and availability. It's usually talked about being a triangle or a triad because you have to decide which things are most important. And sometimes two of them are most important, or sometimes only one. What I mean by that. So if you have a public website, on that website, confidentiality is not important at all. It's a public website. Integrity is important. You don't want people to get on that website and deface it. And availability might be pretty important, but let's say it's a normal company, and if you're offline for maintenance on a weekend or a holiday, no big deal. So in that particular case, in the triangle, the integrity would be the key pinnacle of that triangle and what you're most concerned about. And then confidentiality would be the least, and availability would be the middle of the ones that you're concerned about. But as Dennis Hughes writes here, there's old adages about the fact that the only secure computer is one that's, basically unplugged, has no wires, encased in concrete, and steel, buried underground, etc. Very funny, etc. But the point is, when you do that, you've got zero availability. So there's always a balance between security and availability and keeping the integrity and the confidentiality. And walking that balance is how you do it as a secure programmer. All right. Next thing, couple of tone setters still left. Handling passwords. So very happy that over the last few years, we've seen a lot happen with password complexity stuff. If you're not aware of it, NIST, which is a U.S. National Institute of Standards and Technologies, which publishes the digital identity guidelines, has made two major changes over the last, I guess it was 2 summers ago now. One of them is that basically they said they recommend against complexity. So those are things like, for example, if you're required to use, 8 characters and one has to be uppercase and a special character and a digit, etc. What they basically said is by requiring these special things, that you get less benefit than you might expect. Studies showed that basically people started using very, very formulaic passwords and adding some special characters to it. So unfortunately, it didn't make the passwords more secure. Similarly, one of the big researches that came down was from Microsoft. Having passwords reset, periodically, every 30 days, did not improve security either. So don't require that. If you have a reason to believe that passwords have been compromised, totally different. Change all the passwords. But beyond that, using any type of password complexity and using password requirements to change them, not good. Instead, what you should use is you should use long passwords. In fact, what we call them is we call them passphrases. There's a wonderful comic out by XKCD. I can't believe I don't have it in the slide. I don't know why I forgot that, but it's the XKCD password generator is a website you can go to. And additionally, there's a Perl module for it. It's actually called HSXK password. And that module will give you passphrases. And so in the example on XKCD, they use 4 words. I think it's like battery, horse, staple, orange. And the key point is 4 words, very easy to remember, very complex, much, much, much more complex than the passwords that we're used to with uppercase and lowercase, what we would call elite technology. I usually recommend things like, for example, my wedding anniversary is January 1, 2020. It serves a couple of purposes. First of all, it's very, very complex, so it meets the passphrase requirement. Additionally, it's very easy to remember for you. And third, it makes it very, very easy for you to remember your anniversary. So the final thing I'll leave you with is hashing and salting. If you're storing passwords and you're not hashing them, you've got a problem. Hashing is just a simple one-way cryptographic hash, such as SHA-256. Salting is where you add something to that password before you hash it. What the salting does is it makes it so that you cannot have brute force or rainbow tables done against your information. So very, very important. And if you're not familiar with it, I recommend highly that you go look at the website haveibenpwned.com. That's haveiben and then pwned.com. Great website. You can plug in your email address, or if you're a domain owner, you can plug in your domain. You can see how many times your email address or your domain's email addresses have been compromised in compromises out there on the internet. And this is why we do things like try and tell people to use unique passwords and things like that, because they'll compromise somebody else and then use those passwords there. So a little bit more, then I'm almost done for this, and we'll get into my dirty dozen part. But please support multi-factor authentication. That's typically where there's something you have and something you know, a passphrase and then a PIN. The Google Authenticator is free to use as an app on many mobile platforms, and there's a simple module to use it, Auth Google Auth. Additionally, password reset capabilities. We talked about password resets when you get compromised, but those become a key attack. People go through mailboxes when they compromise them. They look for resets. They try and build a matrix of data. So reset emails should only be allowed to last for a very short lifetime, 24 hours or even less. Other than that, the key point is when you do a reset, send the user an email. Tell them, hey, your password's been updated. Thanks. That can let them know if there's something nefarious going on and somebody else is trying to compromise their account. All right. So, Dave, do we have any questions before I go to the next section?
Nobody's raised their hand,
okay.
So I'm going to say no.
All right. Well, normally when I'm at conferences, I pride myself on...
Actually, there was somebody that had actually a question he was asking in chat, but I think it's worth surfacing to you. Please. So he's saying, with a small set of dictionary words, wouldn't that be too easy to brute force? And his example of a small set was maybe 10,000 words.
Unfortunately, I don't have the data on it, but my understanding is anecdotally, no, that it is extremely complex. And in fact, I'll see if I can't bring up the XKCD passphrase
It was actually linked. Oh, the comic was linked in chat.
Yeah, so there's actually on this website, this is what kind of got me started on it. They actually wrote this article about this. This is several years old, but the bits of entropy, if you look just with, it was correct horse battery staple, was 44 bits of entropy as opposed to Troubadour ampersand 3 only had 28 bits of entropy. So basically the entropy is very, very high. At the time period this was done, it was the equivalent of 3 days of computing time versus 550 years of computing time. So even for basic words, as I understand it, the entropy is still astronomically better than what we're traditionally using in passwords. All right. All right. Well, I have a question, and normally when I'm face-to-face, this is when I give out a book or something like that that I've brought as a gift. So who can tell me the name of the first all-electronic computer? Anybody? Mark Gardner raised his hand, so I think we got to unmute him. He was first.
Was it ENIAC?
It was ENIAC. So this is normally, though, when I would tell you you can't have the book unless you can tell me what ENIAC stands for. So it's electronic numerical integrator and computer. So the neat part about that, and the reason I brought that up as my quiz for this conference, the term bug actually comes from ENIAC and similar computers where they used vacuum tubes, and each vacuum tube was the equivalent of today's transistor. So it was a single on or off. And one of the vacuum tubes got a physical bug in it, like a fly, and that is actually what broke the system from working. So the term that we use today, bug fixing and whatnot, actually goes back to ENIAC and similar vacuum tube-based computers where they actually had a bug inside the actual vacuum tube. All right, so that was the tone setters. Now we're going to go into my 12 dirty dozen rules to basically do secure programming. So the first one I thought about a lot. I don't know that I like the order of this. There's so many of them that I wanted to put first, but what I basically started with here is use a software development lifecycle, an SDLC. Very simply, start with things like gathering your requirements for the program. Think about building in the security, what we call baked in, not bolted on. So security should be first. This is something you should think about from day one. One of the biggest problems that I get when I'm doing remediations is people do things, they set up a database structure, or they originally start doing the programming with elevated privileges, and a couple of years goes by and everybody forgets that that's the case. And the next thing we do is there's a compromise. We go back in and go, hey, why is this database like this? Or, hey, why are you doing this? And they go, oh yeah, we started doing that and we forgot to fix it. So the next thing that we do is we do a lot of agile techniques. So we use a Scrum, and in those Scrums, we do a think evil section where we basically say, okay, how can you hack this system? What is wrong with this design? If you guys aren't familiar with Scrum or Agile, there's a wonderful YouTube link for Scrum in 2 minutes. I recommend every team look at it. It's a great way to really revise what you're doing. And even if you're not going to use full Agile, and you're not going to use sprints and things like that, one of the things we do at our firm, and we do this for things not even just involving programming, is we have Scrum stand-ups every single day. And during that, we have 3 questions that are asked. What did you do yesterday? What are you doing today? And what are your blockers? And then if we're doing software, we will talk about the think evil and how can this be hacked. So with that, you want to use test-driven development. Ideally, writing tests before you even start writing code so that you know, is it secure when it's done? And then finally, use pen testing and pen testing validation concepts and bug bounty programs. I talk a lot about changing the culture in companies, and that's what I talk about, bug bounties, acknowledging bugs. For example, if I go to a company and in the National Vulnerabilities Database, they have things called CVEs or vulnerabilities that are tracked. If I see a program or a software that's in there with 0 of them, I don't think that's good. I usually mean that they're hiding. They're not telling what's going on. They're not ethically disclosing the bugs in their software. So, think about changing those cultures. The USAF Fast Track with the United States Air Force is a concept. Instead of using risk modeling, what they do is they pen test the software and then use that penetration test as the baseline. Kind of an interesting way to do faster baselining. So something to think about. All right, number 2 problem, input validation. Luckily, Perl is wonderful for this. So the key thing with input validation is you never trust user data. You have to validate it all the time. So for example, I'll go to the number 2 first. learn your regular expressions. Regular expressions are just unbelievably powerful. The talk that was, I guess, 2 before mine on ingesting, terabytes of data, unstructured or minimally structured data, talked about using 1,000+ line regular expression. I can't even imagine writing one that long. But this particular one here is very simple. It just searches for everything that is not 0 through 9 and replaces it with nothing. So it's a great way of sanitizing something and saying it's a number. Very simplistic, but you can build on this type of stuff. So we have similar things for doing email addresses. We'll talk a little bit about that, etc. Additionally, one of the things that I get a lot of problems with security is that people do lots of UX design on their websites, and they check to see if the input, for example, is a number. But what they forget to do is they forget to do it again on the server side. So what I usually try and tell people from a security standpoint is all of your validation inputs must be done on the server. If you also do them on the client side, that is just to improve their user experience. That's it. So, if you have something that checks to see if it's a good email address and you do that in the browser, that's just to save them extra steps. But you still need to do the check on the server as well. And then finally, if you take data from a user, try and sanitize it. Try and get it to the point where it's trusted so that you don't have to keep doing it and it doesn't creep in later on in any dynamic functionality. What I mean by that is, say, for example, you have a field that asks for the person's name. Well, validate the name that it doesn't have anything sinister in it, store it in a different hash, for example, and then you can use the sanitized hash throughout the rest of the site. And then you don't have to remember that, oh, I've already sanitized it in this function, or is this before it got sanitized, etc. It is already done. Kind of the similar to the bless functionality as well. All right, commercial break. I will mention libraries for input validation. One that I'm very proud of is NetValidMX. I'm the key author for that. It's up on CPAN. We recently released version 2.50. This has been used for a long time, decades at this point, I think, decades plus. It's tested literally trillions of email addresses. It's used on a lot of servers to test whether or not you can email that server. And it does a little bit more than just your regular expression of, is this a valid email address? It looks for the concept of, is this a valid email address? And also, can this person receive email? And between those two of it, it can tell you if they've got a valid mail exchange or MX record. So something to look at. That's one of my modules. It's very useful for that kind of stuff. But there's a lot of modules out there for doing validation, so definitely take a look into them. All right, number 3, and this is the one that I most heavily debated putting number 1. This is probably the number 1 issue that I see in incident responses is SQL placeholders or lack thereof. So SQL placeholders also are known as bind values, they're known as parameter markers, but basically it's the difference between having a query, such as what I've got in number 1, where you have select star from this, where user ID equals ID. If ID contained malicious data, such as the little Bobby tables, which we'll see in the next screen, you have a problem. Very, very simple fix that has existed, I don't know, 20, 25 years at least, is you use what are called SQL placeholders. And so in this particular case, where user ID equals question mark. And then basically your database queries are automatically sanitized and you don't have to ever worry about SQL getting injected. And, as the XKCD somewhat humorously, unless you've been hacked recently, shows, SQL injections are really quite easy to do on many websites. If I'm doing a penetration test or I'm doing something where it's where I'm looking for it, I will literally type in things like in a name, I'll type a single tick mark and I'll look for an error. And the error will come back something like, unbalanced, tick marks or something like that. That type of error tells me they're trying to put data in unsanitized. This is a big problem. We find it all the time with people. Like, we go into the trouble reports and somebody was trying to do something like register, Bobby O'Shaughnessy, and they can't do it because of the apostrophe. And we go, okay, that's because you're SQL injectable on your name and you have a bug in, how you're sanitizing that. So don't be that person. Use SQL placeholders. And we have a question from Cameron Talks. Can we go ahead and unmute him, Dave?
People can unmute themselves just by the way.
Okay. Can people hear me? Yeah, sorry. We couldn't find out where the raise hand button was. But going back a little bit to talking about validating input, I was reading the other day about Perl's taint checking mode. Would you recommend using that? Have you used that before? Or...
I have, and it's excellent. I just don't know how I would bring it into play on an entire ecosystem of web and data that I'm getting from other sources. I mean, Perl's strength, of course, is it's a glue language that can take output from all these other places. So unfortunately, most of the time I'm using records that are stored in hashes, and I create a blessed hash, basically. And then I know that data is validated.
Okay. Thank you.
And I think we have 2 more people. Go ahead and just, I can't tell names, unfortunately, so. Oops.
All right, I'll jump in there. So you talk about sanitizing data. Do you prefer sanitizing over just rejecting bad input?
Yeah, because, you know, the vast majority of the time, you know, if you kind of look at, eBay has a wonderful phrase that I like, which is basically that 99.9% of the people are just trying to get stuff done, and they're basically decent people. Unfortunately, there's that 0.1 or 0.001% of people that are bad actors that are ruining it for everybody else. You know, as the idiom goes, you know, this is why we can't have nice things. So the reality is that most of the time it's user error. And so anytime I can do something that sanitizes the data to fix it for the user, the better. A really, really common thing that you'll find in NetValidMX, for example, is if you put trailing or leading white space on an email address, it will pass you back the email address without the leading and trailing white space, just because people always enter that wrong. Another thing that we do that's really minor is if somebody types like, you know, Bob at AOL, it'll automatically add .com for them, or Gmail, it'll do the same thing. And those type of little tiny fixes are just meant to try and help the user. So yeah, if it's possible, I will try and sanitize the data and move forward as opposed to throwing an error. Darren, I see your hand raised.
Yes, just following that. You can hear me, right?
Yes, sir.
So I agree with what you said about sanitizing in a lot of cases. However, I would tend to lean a little further in the direction of rejecting, because depending on the case, sometimes the solution for sanitizing may actually break something. Like, for example, automatically adding the .com. If that was just done generically, well, what if the actual domain was a .net or something? Then suddenly you've registered it to the wrong thing. So,
well, we only do it in very specific cases, like literally AOL, you know, is one of the ones. People would inherently forget to type the .com when they would do at AOL, for example. And a lot of that had to do with the fact of when AOL was launched in their internal mail systems.
Right. So that's good. Just always erring on the, if in doubt, always error it rather than change it.
Yep. You know, do what I do, except when it's wrong, and then don't. So thank you, Darren. All right. So after that, here's one of the biggest problems we get. And, you know, especially with the, I don't know what I've got on my screen there. I think I was starting to put something, or somebody was doing a whiteboard. I don't know. Any case, the key thing here is that errors are too informative. What this means is you have to be very careful what you show that an end user can see, or perhaps a bad actor. You know, error messages that say things like, for example, error can't write to blah, blah, blah file name could tell me a lot about your file system, could tell me what operating system you're running, could potentially lead to disclosure of sensitive data. So in general, we do things like, you know, we try and give errors that are fairly generic with a timestamp, and then basically with that, the tracking number, we can then go to the logs, which kind of leads into what I call log. So number 5, my big thing here is improve your logging. In general, you want to make sure that your logging does not include passwords or sensitive material. The only times that we do passwords is we do it with bad actors when we're doing sacrificial lambs, which are boxes that we put out there to kind of get people to attack them so we can see what they're doing. But short of that, you want to make sure that your sensitive data is not in your logs. Additionally, you want to restrict your log access, and you want to make sure that you log those validation errors. So as Darren was pointing out, sometimes they can be problems, and they can also show signs where attackers are attacking, looking for weaknesses in your system. So a lot of people ask me sometimes how I've discovered so many 0 days and whatnot in the vulnerabilities. A 0 day is a vulnerability that's not known publicly yet. And I've had the privilege of turning in some 0 days to some pretty large companies. And the funny part is a lot of times I'm not the one discovering them. I just set up systems that I look at what bad actors are doing, and when I see them doing something new, I try and get them to show me what technique they're going to do. So in any case, the last thing I'll say is look at consolidating your logs. You can do things like syslog out all to a combined system. You can go to something more complex called a SIEM, SIEM, but the E is silent. You can also look at things like Elasticsearch or an elk stack, all open source, great way to store your data and then surface it and visualize it with Elasticsearch, Logstash, and Kibana is the elk stack. Additionally, autonomous blocks. So what this means is, SOAR, just autonomous response. The big thing that you have nowadays is there's so many systems getting attacked. And in fact, if you just put a machine up on the internet, within a few minutes, you will generally see attacks start on the system. They're literally just attacking every IP address out there. IPv6 fixes this a little, but IPv4 definitely it's a problem. There's easy tools out there like fail to ban that can easily automate blocks from your logs. There's a lot of recipes out there, and they can look for things like, for example, if you're using WordPress as your main CMS for a website, it can monitor that and look for brute force logins and then block that IP address. But the nice thing with fail to ban is it will release the ban after a certain amount of time. You can configure it that way. But administrators can be brute forced out of the system or DOS'd out of the system by using these type of techniques. So you have to think evil, think about how people will use your own systems against you. And the way we normally talk about that is consider rate limiting and blocks per IP address, for example. All right, number 7. So we alluded a little bit to this when we were talking about one of the problems we get where people start with a program and we come in and ask them, why did they do this? And the thing is, it's principles of least privilege. This basically means when you start developing your code, please start developing it with the principles of least privilege in mind. Things I've seen and things I've made is, I get on a box and the first thing I do is I turn off SE Linux, or I used to just do grant all on databases to users. Or I would use a root level access thing for general work or for backups or something like that. Don't do this. These are things that lead to, in the long term, to problems. Spend the time, figure out how to do SE Linux. Figure out how to give only the privileges that are needed for a database. For example, you're running a website. How often does a website need the ability to drop a database or drop a table? Probably never, so don't give those privileges to it. And you would not be susceptible to the little Bobby tables SQL injection that we talked about earlier, because your database wouldn't even have the rights, the user, accessing the database from your website wouldn't even have the ability to drop a table or a database. So other than that, I'll just say, when you're using elevated privileges or sudo, use it for as short a window as possible and don't use it for programming. Nowadays, I run all my releases for Spam Assassin. I now run with a non-privileged accounts, so I can make sure that the releases work without that. Next thing, number 8 of 12. How are we doing on time? We're doing okay. All right, good. So this one is pretty simple. It's basically just have an incident plan. When you have a problem, speed matters. So normally, if I'm going through incident plans, some of the ones that really make sense to people are, pretty simple. CEO leaves a cell phone in a cab. Who's his carrier? Do you have remote capabilities to wipe it? Does he have encryption on it? Things like that. What's the phone number to call this, or what software do you have installed on it? Where are the credentials stored? Things like that can help you react very quickly. And oftentimes it's not a funny joke, but I usually tell people don't panic. Even if you don't have an incident plan for a specific thing, even if you pull a piece of paper out and the paper says, you don't have a plan, but don't panic, that can actually help, because then people will go, okay, we don't have a plan. Let's go powwow and find out what our response is going to be and spend 5 minutes calmly thinking about what our triage is going to be and how we're going to attack this problem. And as you go through these type of problems, write them down, keep them at hand. What do you do if a password's been compromised? What do you do if your account has been compromised? What do you do in specific situations that will occur? Do you have to notify authorities? Do you have to notify customers? Do you have to notify insurance companies? Things like that. Some people don't realize it, but a lot of cybersecurity insurance, if you don't notify them within a certain period of time, they are not, they do not have to cover you for that outage or that incident. So very important to have these. Next thing, this one's something I talk about a lot, especially with new people, but this one I'm very happy to talk about a lot, is have a moral compass. One of the ones that I love, I call this the IT 10 Commandments, is the System Administrators Guild, or now Usenix, Code of Ethics. It's a very, very good framework. And let's see if I can load it up. You know, this is the type of framework that any IT person can get behind. It's very, very simple. You know, I will maintain professional conduct. I'll be honest in my professional dealings, etc. If you have a problem at your work or somebody's asking you to do something, you can go read through these ethics guidelines. And there's only about 11 of them. It's many years old, you know, almost 20 years old now. And I can tell you, I haven't found many loopholes in it, and I haven't found where it has served us wrong. So a moral compass can really help you, especially when you're unsure what to do. And I have no idea why I'm going all the way back to there, but let's see if we can get this working. Fast forward a little bit. Additionally, if you're looking for something a little more advanced, there's the qualified ethical hacker or the certified ethical hacker. I usually won't talk about specific offensive cyber techniques until I know everybody in the audience has a QEH or a CEH certification, because as I mentioned, I don't want to be the person you have to call to say, hey, the FBI is at my door because I did something stupid and I need help. So follow the ethics guideline, think about more certifications are it, use a moral compass with this stuff. It'll help you in things like ethical disclosure. It'll help you if people ask you to do something and you're not sure it's right or wrong. You can think about it. And I'm always available. My LinkedIn credentials are there, but talk to your community. You know, say, you know, hey, somebody's asked me to do this. What do you think of that? You know, this stuff isn't written in stone, and you know, the open source software and Perl and things like that have changed the way computing works in the last 20 plus years. So this stuff is evolving constantly. So you need a moral compass to help point you in the right direction with new things. All right, number 10, we talked a little bit about the vulnerabilities database, the National Vulnerabilities Database. The biggest problem that we see is not tracking CVEs. So in particular, not to call this one out badly, in fact, I'm trying to give a compliment to cPanel. There was a issue identified with XIM, very bad one. It was the, what was it, the plus or $sign squiggly brace run, and you could run any command by sending an email to somebody. So you could email root plus $sign squiggly brace and some commands, and it would run those commands as the user you were emailing it to. XIM never meant for that to be in a public release. They just messed up and didn't take it out. Long story short is it was fixed very, very quickly. cPanel put out urgent updates for it. And the reason I'm showing this particular one is that even though this was last summer when this was out there, just a few weeks ago, the NSA had to put out a warning that this is being exploited by the Russians quite heavily with XIM. So for those who are at this meeting, if you're not using if you're using XIM, you're not aware of this, go make sure you're patched. But additionally, the key thing is, as a secure programmer, if you're looking to be a higher level security programmer, think about monitoring things like the National Vulnerability Database. You can look out for libraries you might be using, programs you might be using in your solutions, and making sure that they're patched so that doesn't become a big giant garage-sized door hole. And this one's huge. I mean, this is the absolute worst of them because it's arbitrary remote code execution at elevated privileges. So you can run a command as root from remote very, very quickly. Okay, this one is also one that I consider putting number one. This is the number one issue that I think exists today when I come into programmers. So what I normally do to find out if you have a problem is, what is your process for going from development to quality assurance to production? And the example I give is, you know, I'll pick on Darren since he asked a good question earlier. You know, I go, Darren, here is a bug in your code. Here is the fix. Yes, thank you for the wave. Here's a bug fix for it. It's a one-line bug fix or a one-character bug fix. And then I ask, how long will it take you to put that into production? And I unfortunately sometimes get answers that are months for that type of answer. It should never be months. Hopefully people tell me, oh, I've got an automated process for that. We can push that into production and we can have an emergency release out in a few minutes. That is what I want to hear. A few hours is okay, a few days is okay, but months is completely unacceptable. And sometimes the companies don't even have any ability. So they're afraid of breaking everything because they don't have any ability to get anything from development to production. And this can really stall both development as well as security issues. So thank you for being a good sport there, Derek. The last of my dirty dozen is really to kind of avoid stupid mistakes. The first way I do that is pair programming. Pair programming comes from extreme programming, which was a subset of Agile. It kind of predated Agile, actually. But basically, it's where two people look at it. One person drives the keyboard, another person looks at the screen. These days, we use a lot of things like Google's Hangout Meets and Zoom and things like that. So one person's looking at the screen while another person types. It is wonderful. It lowers your QA. It fixes bugs to start with. Thank you. Additionally, it kind of gives you a peer review right off the bat. The next thing we do is code that isn't pair programmed. Always we use peer reviews. Somebody else looks at the code before it's committed. That really, really helps identify security problems and bugs and just what I call stupid mistakes. So one person writes it, another person commits or accepts a pull request, for example. And then finally, I'll give a little plug. This is on my speech before, but I was asked to do a lightning talk on Talk to the Duck. So I'll be doing that tonight. But Talk to the Duck is basically a great technique for learning and walking through problems or looking for bugs and figuring it out. So if you aren't aware of the Talk to the Duck concept, please attend my lightning talk tonight. I think they start at 5:30 p.m. Eastern. And I think I'll be towards the end because I use a lot of humor in my talk. So we'll have it towards the end of the night. For homework, again, on the humor side, is to watch The IT Crowd on Netflix. This is probably the single best show out there that bridges the gap between technical and non-technical people. And with that said, I've got, I think, one or two more slides, but are there questions out there? I think, Darren, you had a question. Two people have raised questions.
Yeah. Yeah, I don't know if you are suggesting otherwise, but I would argue that even when you do pair program, you still want to have separate code reviews from others, because those that are pair programming still have their sort of their minds along the same track, and somebody who's more distanced, a reviewer, would have, it's still important to have that input.
Yeah, I certainly would say that more is better, but you know, in the realistic world, sometimes you just don't have that kind of staffing to make that happen. So what we do is whoever drives the keyboard, the other person has to do the commit or the pull request. And they're the one that's given grief if there's a bug in the code or if there's a security issue in the code. But yeah, I'm all about multiple pairs of eyeballs on code. At the Apache Software Foundation, for example, you know, we have rules around voting and 3+1 votes and things like that. And we go into a review then commit mode versus a commit then review, CTR versus RTC. You can read a lot about that on apache.org if you search that, or if anybody's interested, reach out to me otherwise. And
at least at my company, we have over 100 developers, so it's easy enough to get extra eyes just for that quality.
Absolutely, yeah. Somebody else was raising their hand.
What are the differences between those two ethical hackers certifications? Why are there two of them?
So the two of them are really listed because they're competitors to some extent. Qualified Ethical Hacker, and as a conflict of interest disclosure, I am an advisor unpaid for Security University. They're the Qualified Ethical Hacking. CEH is a DoD standard, so you might not be in a situation where you can take a CEH certification. So they're just different examples of ethical hacker certifications that are out there. So it's one or the other, not both usually.
Thank you.
Absolutely. All right. So, oh, I thought I had more stuff on here. I think I must have deleted that slide. So other than that, I will just end on the fact that the IT Crowd is hilarious. I think it's one of the best shows out there. So if you haven't seen it, make sure you watch it. And other than that, I think I finished 6 minutes early. So if there are more questions, I'm happy to take them for a few minutes. Otherwise, I will hand things over to Dave and see you all at the lightning talk later on this evening.
Any questions? Raise your hand in chat, or you could just unmute and ask it. That's fine. All right, M. Wheat, go for it.
Can you hear me?
Yes, sir.
I was wondering, you talked. I came in a little late. You were talking about passwords and long passwords. What do you think about secure shell and key encryption? secure shell public key.
You mean like PKI? Is that what you're talking about?
I mean, like just forgetting the password entirely and just using SSH, the .SSH public
Yes.
and private keys.
So you're still going to have a passphrase to encrypt your private key. So you're still going to have that there. Additionally, I work in realms sometimes that are a little bit scary for people, but generally we start to worry about things like, for example, something you know, something you have, and also worrying about things like torture and being able to have passwords out there and things like that. So we actually use systems that, for example, we have pins where the pin will let people in the system, but it's an alert pin. So you have a pin that works, and you have a pin that works as well, but also alerts security that you've been compromised, things like that. So, there's still a place for multi-factor authentication. Passphrases are important towards that type of thing. And, like you said, something like a pin on a phone, as well as a passphrase, as well as having a private key, I think is really the better model to go. And I will tell you that even though I know of cases that exist, such as things like SIM jacks and things like that, I have yet in my career to work on a situation where a multi-factor system was what led to the compromise. They happen, especially in some very, 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 very targeted attacks. But I will tell you that the average person, multi-factor authentication will get rid of 99.9 and a whole bunch more nines of your attack surface for attacks. By the way, my LinkedIn is here. I'll take more questions, but I do welcome people. Just tell me, hey, you were at this meeting, and I love to talk to people on social media, especially LinkedIn's my choice. Whoever's raised your hand next, unfortunately, I just have 2 hands raised is all.
Yeah, Christopher White was first.
Okay, Christopher.
Wrong button. There we go. Thanks very much for the talk, Kevin. I work in embedded software for autonomous devices. Any advice, Linux usually, any advice for the embedded sector or any things that
Yeah, sure.
watch out?
So one of the tools that I've been mentoring for a little while now that I love is a product called Apache IoTDB. IoTDB is designed for logging very, very significant amounts of data. So for example, it can, with a single server, ingest over 500 million data points per minute. I would, not to throw any specific database under the bus, but I would say throw, 500 billion data points at a, by the way, that is 500 million, but we do 500 billion in a day, for example, of logging, and throw a half a trillion rows into a database and try and do a query on it. And it won't work. So Apache IoTDB is a type of database that is called a time series database. And so it's designed to store timestamp data very, very well and very, very efficiently and do queries from it very, very efficiently. And so when I'm looking at IoT devices or embedded devices, again, logging is one of the biggest issues that we see. So we want to have offsite logging. We want to have very, very lightweight logging. And then we want to have the ability to do stuff with that logging. And so if you want, I can send you some of my slide decks about Apache IoTDB. But the whole thing that we do there is we're trying to cover the entire life cycle of the data. So for example, we want to log the data. Logging is number 1. We want to be able to analyze the data. That's number 2. And we want to be able to perhaps visualize the data. And we want to be able to store the data long term. So a really example that I had that started me with Apache IoTDB is we were dealing with a wind farm that had a thing called a derecho that attacked it. Derecho is not a cyber attack, it's a physical catastrophe, which is another part of cyber, is protecting against physical catastrophes. And there was another derecho that was that was forecasted. And so with that, they said, what do we need to do and what can we expect from this next derecho? How's it going to affect our wind turbine field? And basically I went back, I talked to NOAA and came back to them with some data from the NWS, that's weather service stuff. And I said, okay, the last similar event that they were predicting was February 23rd of this date. Let's go look at your data for that date. And they said, we can't. We delete all our data after 30 days because our data, we can't store data longer than 30 days. It brings the server down. So that's a failure of logging. Apache IoTDB fixes a lot of that because it can run on the individual, like Raspberry Pis, for example. You can run around and grab SD cards out of your Raspberry Pis to collect the data. You can have a cell phone that uploads the data, etc. and then it can ingest it all into a system. The Shanghai Metro uses it with radio antennas that upload the data and things like that. So it's a way of collecting the data. And then each of the servers uses what's called TS files, which are like zip files for the data. And so you can just take zip files out and store them and bring them back in as you need them. And as I mentioned, it can deal with, literally trillions of data points. And on top of that, it does a lot of things for out of order data and for not locking the database when you're doing ingestion of data and then you want to do queries. So if you have a system where you're constantly getting queries and you're doing half a trillion rows in an hour, for example, you can't wait for those queries to be ingested to get your visualization if you're looking at a real-time attack. So it has some solutions for that. Just off the hand, that would be the #1 thing that I love. Also, there's a group called cs2ai.org. That's Charlie, Samuel, the numeral 2, A as in Apple, I as in indigo.org. That is pronounced CISA, and that is a cyber something systems group. So that's basically a OT, operational technology, and that embedded Linuxes and embedded devices for security. Some great talks both at the local levels. I think there's quite a few hundred chapters now, as well as the overall global chapter.
Thanks very much.
Absolutely. All right, how are we doing on time?
I think we can take one more question if it's quick, and we have one hand raised from Patrick.
All right, Patrick, you are the last person of the night.
Thanks, Kevin. My question is, do you have any recommendations for static application security testing tools?
Yeah, so there's pretty much 3 big ones, and unfortunately the reasons for recommending one over the other. So you have pretty much Veracode, you have White Hat Security, and you have Synopsys now, which owns Black Duck, and all of them can do static SAST. They can do dynamic. They can do source code analysis, SCA, which can check for libraries. But the bad part is they have different models for their pricing in different situations. And so unfortunately, sometimes it needs a bit of analysis for your exact application as to which one will be best, because the pricing and the differences between the 3 can be pretty varying and whatnot. And if you tell me like, oh, you're trying to deal with open source, you might find this one over here better. If you're working with one particular language, some of them work better in one than the other. But the 3 products that I would be looking at are White Hat Security, known as WHS, Black Duck, which is now owned by Synopsys, and then Veracode, VERACODE. And if you email me, I'm happy to tell you some of the parameters that you might have, or I'm available for consulting at InfoShield as well if you guys need some help on that stuff.